In this video, I'll walk through a couple of examples of solving an exponential equation. The first one is 100 equals 35 plus 4 to the 2x. So what we want to do when we are solving for an exponent, right here, we want to isolate the base and its exponent. So 4 is the base, and the 2x is the exponent. So we want to isolate that, get that by itself. So to do that, we'll subtract 35 from each side. And that leaves us with 65 equals 4 to the 2x. At this point, once you have the base and its exponent isolated, then you want to take the logarithm of each side. Now, you might take the log base 10 or log base e. I like to take the log base e. That's the natural log, and the reason is because sometimes we have a base of e. So we'll get to that one next. So I will take the natural log of each side. So I'll just write ln, and now, by properties of logarithms, here's what I'm going to do. First of all, I'll evaluate this natural log of 65. That is a number. So natural log of 65 is approximately 4.174387 equals. Now, properties of logarithms tell us that when we take the logarithm of something raised to an exponent, we can take that exponent and move it out in front of, or multiply it by, the logarithm. So I'll rewrite that as 2x times the natural log of 4, and then that becomes 4.174387 equals 2 times the natural log of 4, and the natural log of 4 is 1.38629,436, rounding it someplace, times that x that's still there. And then all we do to solve this is divide each side by that coefficient, so 2 times the 1.38629,436, and you could multiply that and then divide it into the 4.17, so on, and in the end you would get x equals approximately 1.5056. I've rounded here. Okay, the reason I held on to so many decimal places further up is because you could have a rounding error. So hang on to a lot of decimal places until you get to the end. And even at the end, I've held on to a lot of decimal places. Okay, so that's one example. Here is the next example. 8.6 times e to the negative 1.2x. Now again, we want to isolate the base and its exponent. The 8.6 is not part of the base. It's just being multiplied by e to the negative 1.2x. So what we need to do is divide each side by this 8.6 so that we can get the base and its exponent all by itself. So 8.6 divided on each side, and we end up with 2.3. Let's see, e to the negative 1.2x equals 2.3255814. And now again, we've got the base and its exponent isolated, and so we are going to take the log of each side. I prefer to take the natural log, and this is why. For cases just like this, a lot of times we have our base is our natural base of e, and so that something special happens, and I'll show you in a second here. We'll take the natural log of the other side. Okay, now properties of logarithms tell us that we can take this negative 1.2x and move it out to the front, and so we get negative 1.2x times the natural log of e equals the natural log, I'm going to leave this as the natural log of 2.3255814, and this is it. The natural log of e is 1. You could type it in if you're don't believe it, type it into your calculator, but the reason is because log base e of e just equals 1. So now all we have to do to get to x is divide by this negative 1.2. So divide each side by the negative 1.2, and if you're typing all of this into your calculator at once, if you did not evaluate that natural log of 2.32, so on, be careful how you type that in, because it does make a difference. So I'll show that right here. It's natural log of 2.3255.8 and so on, and then close this parentheses. This is very important. Close the parentheses and then divide by the negative 1.2. If you don't close the parentheses, it's going to take the natural log and it's going to divide the negative 1.2 into the 2.32 and so on, and it'll take the natural log of that. But you want the natural log of just this part and then divide by the negative 1.2. Okay, in the end we get x is approximately equal to, because I've rounded it someplace, negative, let's squeeze a negative in there, negative 0.7033. So there is the process for solving a couple of different exponential equations.